Okay, so, all right, first of all, projects. So you guys are good. Projects?
No progress.
No progress? Any intuitions? What? Did you have a look at the list?
Not yet, you did one.
Sorry, I didn't get that. There were two people talking at one time.
You have 2 ears.
That's right. Yes. But only one synchronization mechanism, so that's the downside. Yeah, I'm not as flexible. But you guys saw the overview of the different things, right? So what's available there?
Not yet, just updated.
Just updated, like as in now. So 3 more new things for you guys if you want it. And the stream, of course, that's why I'm talking so explicitly, is a suggestion which is more general, which is kind of interesting, is to extend Lab 3 to some extent and build something based on that, right? Basically a game based on the game idea that's in there, right? So that was the idea of those guys there. They want to take it in one direction, but it's reasonably imprecise, so you probably could, take a different approach on, using the same mechanism and your code, of course, but, so you kind of piggyback on the same idea, but you can go into different directions, and it's kind of complex, right? So because you have all those, you need to make a game out of it, right? So as opposed to just having some sort of interaction with the sensor. So that's quite an interesting idea. Ingwe has the idea of having a movie TV series chatting app, so that's his work. He kind of has figured it out already. And the other thing that we added was a application suggestion by the international office. You may have seen that or not. So they want an app that deals with a sense that there's that exchanges basically equipment between students and leaving and coming students, international students in particular, and they look for a mechanism that allows them to manage that somewhat. And I notice here that there is still a bit of a remnant of my inability to copy from PDF. Hang on, those students. So if the stream are interested, or you guys in the corner there, that's probably still a lot of opportunity here. So, but be creative. By the way, the earlier the better, because you have more time, right? So that probably doesn't come as a surprise. So yeah, let's think about it, and so you get something going. What was the deadline again? May 4th, right? So yes, okay. So yeah, we still have a bit of time, right? So 5-ish weeks. That's nearly 6 weeks, in fact. So that should give you enough time to do it. But yeah, you may want to log in as soon as possible. If you have any further ideas and you want to discuss them, just send by email. That's how we did it with some other groups, and then we'll just add them to the list, and you can just start working on it. Cool. That's that. Any thoughts, questions regarding projects from you guys?
I still need a group.
You still need a group? Yeah, you could be possible candidates, right? So, well, But the point is, I think, but you have potential people to form a group with, right?
I guess I haven't asked anyone.
Exactly. So that's usually how it works. You coerce people into saying yes if you ask them, because they feel socially obliged to do that. So it usually works quite well. Exactly.
You want to work with us in this subject?
No.
Wow.
But I need to.
Well, yeah, that's one way. Okay, that went well. One of the better examples of collaboration. So yeah, so it's important. You guys are settled where needed. All right. Since we have 5 people here, you'll probably kick my wife out and move to my home, because then you can do it there in my room. That's probably easier than talking to you in the entire class. That's like interesting. I hope that some more people show up eventually to make it a bit more exciting. So one thing we didn't really talk about, or what do you think we didn't talk about yet? Perhaps you figured out in the mobile class. Cool. It's hard to guess because it's actually happening under the hood, and it's something you have used pretty much every time you used you did any sort of Android development, followed the labs, or did the tutorials, or mucked around with code basically. And did you ever need to explicitly build something?
Explicitly built.
Yeah, have some sort of tool chain that you need to invoke, and not really, yeah? So basically it's all about pressing the play button and everything comes magically up in the emulator, right? So is that the experience you had? Yeah, you have a different experience.
If you don't use a USB cable and for the emulator, you need to explicitly say that you need to build an APK, which you then need to transfer to your cell phone to install it.
That's
Just
cool.
hitting the play button.
Well, yeah. Another condition that you don't have the ADB installed, is that what you're referring to?
Yes.
Right, okay. Right, let's assume we have the case that we have a working emulator and the Android debug bridge installed and some sort of virtual device, so AVD, then you generally would be fine, I guess, really with the play button. It kind of should do the trick. So you wouldn't need to muck around too much with the command line unless you're setting up the Android SDK for the first time and you need to check whether your device actually connects and those things like those. So it actually works quite smoothly. And why does that do so? Why does it work smoothly? Yep.
Gradle build?
Gradle build, right? So did you guys come across Gradle before elsewhere?
No.
Yes.
Yeah?
I touched it once.
In which context, if I may ask? Just for
Modding Minecraft.
modding my, okay, that's not, okay, in a non-university context. Cool, that's good, yeah. Sounds good, yeah, it's a good idea. So Gradle is the obvious tool of choice here. And you found that the integration of the Android projects and Gradle is actually quite rigid, right? So in most cases, you don't need to interact with this, but Android Studio intimately relies on it, right? It's not like you can choose between different tools and install them. And the interaction between Gradle and the actual and Android or Java environment is kind of seamless as well, right? So you it works well together and it fits quite neatly. The only thing is that you need to be accustomed to your the underlying build structure and so on. But I just wanted to kind of at this stage emphasize what Gradle is about, where it's coming from, and how we use it, right? So that's one of the angles that I want to take in this session here. So the question to you, why do we use build tools in general, independent of the fact that we're using Gradle right now in Android?
For it to work on every device that you want to support.
Cool. Yeah, that's cool. So that's mobile application specific, but more generally, we use build tools in a lot of contexts, right? So, and mobile application is one of them. So we want to support multiple devices, platforms, formats, and all that kind of stuff, right? What are other reasons? Why do we use build tools? Why don't we just run the Java compiler over a directory and hope that it compiles everything and then things work? Why do we use build tools in whatever language? Yep.
Probably because there are like a ton of different optimization settings and
Yep.
the compiling settings that is a hassle to do it manually every time.
Cool. That's a very good point. So the kind of the chain, the compilation, the dependencies are so manifold and so different, and there's so many different mechanisms of doing internal optimization that the user won't even grasp, that you lose out on a lot of optimizations. Yes, that's a good point. What else? Do we use external stuff in our applications, or do we do everything natively? Stuff.
I guess we're using libraries.
Libraries, right? So we have a large number of dependencies, right? Often. And even if we are not using them, as you will see later, the platform may well use a large number of those, right? So, but even you have a choice of choosing, libraries for different purposes. We talked about Room some time back, Volley, that you may have used in Lab 2, and so on. So those are simple examples, basically. Or Firebase is another one, right? So cool. So we have different devices. We have different libraries that we want to use. We want to support Yeah, what's another good reason for using build tools? This course, yeah, it's okay. It's not the perfect example here, so other courses make better use of that. But what's another reason why we use build tools? Think about all your devices or platforms you're using. Are you all running Windows? No, lucky you. So, no, you're not. So you're actually kind of in a very heterogeneous space, right? So, and it's probably a lot easier to have one tool that does the job independent of the platform you're running, right? Whether it's Mac, Windows, or any sort of Unix or Linux flavor, right, that you have available. So those are some of the points, and you can go on and go on with this idea, but the key idea is about automating complex tasks, right, that have linked dependencies, run on multiple devices, and you may have different variants of applications you want to build, right, for different user groups, right, for example, for you know, a simple user interface for elderly citizens, and a more detailed interface for expert users, and then one for the intermediate users, and so on. So you may have different flavors of your application as well that you may want to build. Even though the mechanics are the same, for example, user interface may be different. You want to automate all those different choices, complexities. Another thing you want to automate, what's that? What's also something we didn't talk about yet, but you will expect that we talk about it. What's very important in application development before we deploy and before we deploy and deliver it? Testing, right? So you want to automate testing as well, right? So in some languages that's kind of semi-automated, or at least quite well built in, like Golang was a good example, right? So you have Go test built into as a framework. In Android you kind of don't have it really, but somehow you do, based on some of, you know, historically grown extensions. So, but anyway, every time you want to deploy, you also want to run all those tests, again, for all those flavors and so on. So automation is the key, right? So you want to get as much as possible done automatically without you needing to interfere anything. Of course, that's closely related to the idea of continuous integration that you have heard about. No, you haven't heard of, some of you, the ones that did the code as infrastructure course, I believe. No, yes, but the idea is that basically that you can integrate the entire tool chain when you commit something to a Git repo. It's automatically tested, deployed, and, you know, published, and so on. So to have this automated tool chain process and interlinking those different tools using, for example, webhooks. So yeah, that's one of the most prominent uses for that one. But build tools are an important part of that. They obviously don't represent the entire continuous integration infrastructure up to the deployment on Google Play, even though you could add this to some of build tools. But the key idea is there that you kind of get the basic process going. And the basic process is in the development to develop, to test, to assemble then the code, to deploy it fundamentally, and integrate it. So integration implies if you deal with multiple projects, particularly in an enterprise environment, you need to use it or want to use them together, right? So you have another form of integration, possibly testing involved as well on that level. Admittedly, that's a bit simplified here. It's just focusing on the individual application. And yeah, well, repeat that cycle often, as often as possible, because you want to have a framework that allows you to test as early as possible and as often as possible, so you can identify issues early, refine your tests, and so on. And it should go fast, basically, right? So we need to have that as well. And looking back into the history a bit, so perhaps you guys have some insights here. This it's actually from a blog, but I found it sufficiently inspiring to just put it up here. And the idea is basically there. What's kind of the history of build systems? And there's a large number of them. And this is not a comprehensive listing at all, and it's in fact a bit quite dated. But I think it captures the essence, at least, of the tools that we want to use. Right? Every one of you uses Make or knows Make, right? So from your basic C++ introduction. But you know, Make is kind of what's the limitation of Make? Or is there a limitation? What is it used for? Anyone? No? You don't. You use Make, right? I assume.
Yeah.
For what did you use it?
You're referring to.
Sorry, pardon?
I don't know what
So what are you doing with Make? We get to the issues then.
Building applications,
Yeah, what kind of applications?
multiple files, and those using libraries, for instance. So you add libraries.
Which language?
C and C++.
Yeah, right. So so Make is primarily geared for that use, right? So there are various variants, but primarily it's C and C++, right? It comes very much out of that tradition, and but again, it requires you to indicate many of the optimizations yourself, right? So there's some element of optimization, but you kind of need to still manually invoke the tool chain, right? Of creating the Make file and fundamentally doing the compilation by calling Make after that. So, but that's where everything started. But some people realize, oops, we're coming now into Java world, and Java, in contrast to C++, is not focused on efficiency, but it's focused on building big systems, like seriously big systems, which need to be maintained over a long time to come, like 5, 10 or more years, right? Which is a bit harder generally in C++ applications, for example, for various convenience reasons that Java has introduced. And so the idea was, okay, we need to support this flexibility of having different Java components plugged in together, for example, at runtime as well, and so on. And it needed to have a build system for this one, and that was to become End, known as End. And it's the idea there, okay, obviously we want to be modern, 1990s, yeah, let's use XML. So the entire thing is specified in XML. It's quite flexible, actually, in terms of having individual Ant tasks that you can, I'll probably show you a snippet of that thing, that you can basically run, and the idea is, it will get clearer when I show you an example, that you train individual, it's actually from a tutorial here now, but I think it's a good overview, see if I have internet, or sufficient internet. Okay, let's do it. Come on. So if you have a Java project like this, you could have a build file like this. Is that somewhat, that's on the wrong screen, thanks for reminding me. So, right. So here, for example, very simple Java file. It doesn't do literally anything apart from multiplying something in a very complex way. But the idea here is that this is typically an Ant file. You have an XML file. I'll try to enlarge it a bit, see how that goes. Not really well, but I convey the intuition. The idea is an XML file, you specify your project, and then source file and build directory. So basically it's all about setting up the directories relative to the current path you're in, right? So there's this build file, and it's always called build.xml. So if you see a repository that has a build.xml file in it, you know that's an Ant repository, right? So you can use the Ant tool to build it. And the idea is then that you specify different targets here. Target number 1, target number 2, and so on. So, and you can then call End with respect to those different targets, and all the tasks that are involved are basically done. So if you, for example, say End clean, it will delete the build directory, which is a variable linked to the build directory, which is bin, the docs directory and distribution directory, for example, right? So that's the whole idea about it. And if you want to be more complex, for example, you have the target jar, so meaning build the entire jar file, so you can run it, and you can deploy it, share, distribute it, and provide it. Then you can do it, for example, in this way. And here it specifies what's the destination directory, destination file. But more importantly, you also see dependencies, or let's say, dependencies in terms of targets. So the jar target depends on the compile target, right? So did I get it right here? Yes, compile target. So it will automatically infer that you need to run compile before you run the jar target. And compile itself refers to clean and make directories. So it will automatically first clean, run the clean target, then the make directory target. We pretty much, set everything, clean up everything, and set everything up from scratch. Then do the compilation, and then fundamentally build the jar file, right? So if you, for example, run the main target, it requires to do everything. It will do the compilation, the jar file generation, and generation of Java docs as well. You may know that Java has this Java docs mechanism, right? So where you can have / double star annotations above your methods and so on. And that's automatically used to infer Java doc characteristics. So in this case, the project terminates here. So this is a complete end file that allows you to build a simple project. So, but just to give you an intuition, it's XML based, builds on the idea of targets, and has simple dependencies, right? So you link those individual targets and then you execute them to produce some sort of artifact that you want to use. Cool. So, and this was considered quite powerful. This was considered quite powerful. One of the key limitations, however, is it was generally focused on Java again. So it's similar to having make focus on C++ and so on. It did the kind of the same for Java initially. That's one of the issues, or that's a bit of limitation. The second one is that it's not visible from here because obviously it's not referring to the feature, but the idea is that you can't actually use, you need to have all dependencies locally available. So you would need to basically have a repository that contains all your libraries as well. Yeah, so here, for example, there's an example. If you have the build class path, you will need to say, okay, everything in this particular directory, which happens to be the library directory, will be included during compilation, but it means it always needs to be in your repo. So if you want to use the Android library, you would need to download it upon any incremental change and basically add it to your own repo to be able to build it, right? Which would be incredibly painful and tedious. So it doesn't do anything on its own other than building in your directory. Second thing is it's actually reasonably flexible, and it doesn't prescribe any particular structure in terms of execution order other than giving you the flexibility to say, okay, first run that target followed by the next one and so on, right? But there's no clear build order or sequence or build schema that that is enforced. So the problem there is that every end file is kind of individualized, so it makes it a bit hard to understand them because you need to pass through the entire file to understand how the dependencies line up and so on, right? So limited conventions other than using XML, yeah, and having the idea of targets. Somewhat clear? Quite straightforward, right? Bit historical, 1990s stuff, yep.
So you have a target that has a dependency further down in the XML instead of above. Will it still work, or?
And it's a DOM model, yeah, it would pass the entire thing first. So that should work. I'm a bit on a limb here because I haven't used that in probably a long time, very long time. But yes, because it builds the complete object model before doing the execution, I think the order doesn't matter at all. So, yeah. So that was end. It's the first one, and there's a variant of further tools that have come along from this one. For example. Yeah, various variants that try to get rid of XML again, or wanted to have something a bit more declarative as opposed to the individual target elements. And one of the key players that has crystallized, that came out of it, was basically Maven, and that's that tool. So have you guys heard of Maven before? No, it's fine. Perhaps.
I think the what the fuck is Maven statement is quite relevant.
Yes, that's that may be one way to think about it. That's right. So not okay, but it's pretty much again mid 2000s, one of the build tools for the in the Java world in particular, right? So and the idea was there. Okay, well let's deal with the shortcomings of End and have a more systematic fixed life cycle that is built into the system. And I'll bring that up in a second. And foremostly, which is really cool though, is dependency management. And that's why it's really explicitly highlighted there. The idea is there, you no longer need to provide the dependencies with your own project. You just specify in the build and it will ultimately be downloaded before you actually do the compilation and so on. So everything's done for you, right? So quite flexible in that respect. So the idea of having a centralized or organization-wide repository that hosts all the necessary libraries you need to build your stuff and do that on the fly. So it's actually quite nice in that respect, quite powerful in this respect. And it's still the standard with this in this respect. We get to that in a second. So Maven repositories are around and well. So in the earlier times, especially in the mid-2000s, if you talk to someone who's using Maven, they're usually annoyed because they are, at this stage, we had, especially in New Zealand, it was kind of common to have kept internet connections. So you don't have, unlimited download volume, so you're kind of kept. So, and the issue with Maven is that it kind of, you get the perception that it downloads the entire internet before it does anything. Because downloading dependencies was quite heavy, because it oftentimes didn't only download the ones you actually needed, but transitive dependencies and letter related ones, and then you realize, oh damn, I don't need this one, so I need to redefine my dependencies, download everything again. So it does even cache them locally, which is fine, but if you get it wrong, you suddenly end up with hundreds of megabytes of downloaded data, which is not a problem nowadays anymore, but it was back then. So people kind of were very wary of Maven because of that. But yeah, so Maven is kind of the opposite of ANSI in two respects. Number one, it has dependency management. Number two, it has it follows the idea. It follows the idea of having convention over configuration. So in ANT, you were quite flexible. So you have a fixed XML blocks as with targets that you do, like basically tasks. Think about this, and their dependencies. But there's no single correct build cycle, right? So of how things are actually done, in which order, and so on. Maven took the opposite stance. They said, well, let's not muck around so much with the dependency of the individual targets, like an end, but instead assume that they're executed in a certain order, and you specify the ones you need, and they will be executed. And that was basically the idea there. So I'll show you one example. Hang on, I'll do that later on anyway, don't I? Now we get there in a second. So I go over that in a second later. So, and to come back to why we're using Gradle here, the idea then after that was, okay, so now we have the flexible dependency management, which is actually quite helpful. But again, this build process is rather rigid and very linear. It doesn't support much parallelism in a way. It's very cumbersome to build. For example, if you have an incremental change and you want to rebuild the application, it takes ages in Maven generally because of those limitations. And yeah, it's incredibly verbose. You will see the files later. It's quite heavy on that one. Plus, you can't really refine the life cycle, the build life cycle, which is kind of fixed in Maven. So the idea was there. How to simplify this, and that's basically the idea of Gradle. And Gradle gets away from the idea of being only a kind of configuration-based approach, but actually being nearly a full programming language. In fact, it is a variant of a programming language, namely Groovy. It's actually a domain-specific language, but it looks like configuration files, but actually fully programmable in principle. So that's the idea. Plus, also one of the examples of advantage of Gradle is it's a fully fledged build system for a wide range of programming languages. So it can build for C++, Scala, Java, Ruby. There's a wide range of plugins you can use. Plus, it's compatible with most of the older build systems as well. So if you still have repositories that use end, for example, you can still use Gradle specifications that invoke those dependencies and so on, even though they are built with end. So it's able to interact with those different mechanisms. And the second thing is it actually uses repositories for dependency management, but it uses Maven repositories. So it doesn't really invent a new thing, but uses the infrastructure that's there, because that's the most widely distributed, at least for Java. So that's why. So, but this was just the intuition, okay, where does everything come from, especially in the Android/Java world, and where are we now? Of course, this is totally incomplete, right? So you may come up with a number of other build systems that are not touched here, but this is a good kind of overview in the kind of industrial relevant space, at least for complex enterprise applications. So anyway, All right, so historically Maven was the default build system, and the pane came here. The pane was basically this one. You have a set of default life cycles that each of your builds needs to go through. And that is like validating that everything is there before you build something, then compiling things, testing things, packaging them up, verifying, installing, ultimately deploying them somehow in you know, ideally a repository, so it can be used as a dependency for other projects, or you know, somehow on a website or wherever else, however you would want to distribute it. And the magic here, again, I mentioned it's XML based, similar to End, was that you do that using the POM file. So you may have seen some projects that have a pom.xml in their root, and then you know, okay, those are built with Maven. So in this case, you can just call Maven and run functionality from there. So the idea is it's a XML-based specification. It has the specification for all the lifecycle phases. So and it has a hierarchical organization, which is kind of cool because you can have this POM file at the root of your repository, and in subdirectories they can have individual POM files and so on. So they will be built using the specifications that are closest to the actual code, right? So you can structure your project in a hierarchical fashion, which is quite helpful. The problem, however, that comes from that one is that you may have sometimes a bit of a tough time identifying what's the actual build tasks that are executed on my specific code bit, because you have the more general specification file, more specific one, and where more specific, the it overrules the general specification file. For example, if you overwrite the testing life cycle in the more specific POM file, but don't specify anything else, it will use most of the things from the general POM file and then the testing elements from the more specific one, right? So, but figuring that out can be quite tedious, so it was always a bit of a struggle to figure out what's the so-called effective POM, so what's effectively applied on my source code here, and that was kind of a hard one to debug to some extent. But I'll show you, just to scare you off a bit, the intuitions of how such a specification file looked like. So that's the official page, and that's the so that's the super POM. This is the idea that this is the most generic POM file, and I don't expect you to start even reading that stuff, because you will know why in a second. And if you run through this thing, you'll find that it's actually kind of involved-ish. So yeah, so this is both the most generic super file that you probably find. What it does here, specifying some repositories. No need to deal with the details here really. It just says use the following Maven repositories for any source that for any dependencies you have. For plugins, use a different one. For building, this is the information you need, like target and source directories, stuff like that, and test directories. Where do we put reporting? Yeah, I forgot to mention, Maven also generates reports. So basically, it's like HTML reports you can publish on a website. You see which builds went sideways, and so on. And then you have different profiles, similar to the build targets and end, but here to different endpoints. For example, you can have a test profile, a release profile, a staging profile, and so on, which may have different requirements, dependencies, and so on, right? So, but it's all XML in this particular case. That's a tad more involved, this one here. And what you see here is, this is all boilerplate build stuff, but here it's a lot of different plugins that are attached to this particular POM file. And the reason for this one is, it doesn't support any sort of procedural code. You can't specify just copy that file from A to B, or from or delete those files. You always need to have a plugin that does that for you. So the whole Maven concept relies on plugging in every sort of functionality that you need using any sort of additional plugin, and then use it, which is kind of super tedious in terms of its use. In fact, I have an example. Hang on. It's an own repo I did some time ago, but on mini project, and I had the following problem. I needed to, on the fly, rename the modify files, and I used Maven for that purpose. The internet is a bit slow, it's a pity. Should load it in advance. And just doing a simple renaming, I think that's the one. So it's quite a simple project, but so it was basically the idea, okay, how do we name this thing? What are, it's a parent project, so I have this hierarchical structure. What are the dependencies that I need to use, for example, here? But the pain came down here. The pain was simple as that. What I wanted to do is to replace some source files with something else. And this is basically, yes, hang on, go with, yes. So this is the entire specification of taking a source file, copying it renaming it to, no, copying it to a different file name, modifying the internals, and then copying it back to a target name. So you need to have like 50 lines of XML just to specify that kind of stuff. And the thing you need to use is basically plugins, and this one is called, hang on, which plugin did I use? Execution, right, the move functionality and the copy functionality and so on. So it was actually quite tedious. Right, Maven Replacer plugin, that's the one that needed to be linked. It even goes on here, I forgot that bit, not to mention that. So this does actually in-code replacement. So it copies the file to different directory or different file name, then does in-code manipulation of that file itself before copying it back. So it's like 150 lines of whatever specification just to get that done, right? So that's kind of painful if you think about it. So Maven is good for that. So everything is XML, but if you want to do anything that's remotely meaningful, you kind of won't get around of having some sort of plugin doing it for you. That's why you find those files oftentimes having a massive amount of plugins just to do very simple stuff. Right here, for example, plugin for deployment, a plugin for creating Java doc, and the plugin for that is managing, I think, the source files as well. So that's the idea. And so it becomes quite involved if you have larger tasks. Of course, there can be, the dependent POM files can be quite minimal. It just says things like this: what's your, give me a so-called group ID, an artifact ID, and a version of your code, basically, and it sits in the same directory as your project. You compile it, and everything will be compiled using this those conventions. We get to those ones back in a second. But everything that's not defined here needs to be specified in the super POM again, right? So it's where the hierarchy comes in. If something is not specified, a more specific POM file is in the higher one. So it's kind of tedious to think about this. So basically, that's just an example. Here you see the idea of having this hierarchical nesting, so that you have different directories with different POM files in those subdirectories that depend on each other. So that was basically the idea of, or is the idea of Maven, and then you can invoke different phases of that lifecycle. You can, for example, say Maven validate, Maven clean, Maven test, Maven compile, and it will execute everything until that particular target that you specify, right? So it will ensure that it runs through all those different phases until you are there. Right, so so quite involved, but the cool thing is the Maven repository, and the idea there is similar to you guys who at Cloud. We talked about having repositories for Ubuntu, right? So you download the individual binaries that are relevant for your particular version, and Maven does the same for dependencies. And you have three variants. Either you have a repository that sits on your local file system, and that's generally the one that's basically cache. Everything it downloads in terms of dependencies is cached on your local file system, so it can be quickly and easily reused. Then it has the idea of a remote repository that you can specify. So, for example, if you're in a coding shop, then you most likely have your own repository set up with all the libraries you conventionally use, so they're quickly available. You don't need to download them to every dev machine and so on, so you can do that as well. And of course, you have the community repositories that host pretty much any sort of jar file you can imagine, and you can publish your own one as well. And that actually makes it incredibly convenient from a developer point of view. So I just briefly go to Maven Central, so just give you an appreciation of what it is, because that's probably something you will deal with yourself as well, independent of Maven. And the idea here is Internet is a bit, yeah, cool. That's usually what you kind of get. You see a, or not yet, so there you go. You see some folder structure that is grouped by sort of identifiers. And then those have like Maven metadata and include the jar files for particular versions or even the POM file. So if you have a POM file, it will be able to download the build from source generally, whereas the jar file is the binary. Basically, it's downloadable as well. So both of those elements are available, and everything related to this particular package that you're interested in is specified in the corresponding metadata. In this case, it's called group ID, HTTP client, artifact ID, HTTP client, and the version associated with this. So if you the group ID, artifact ID, it generally think about it as a grouping mechanism. So for example, you have a company that provides several kind of applications. You could group, for example, all financial applications under group ID finance or whatever else, and then have artifact ID for all the different products that are sitting in that particular branch of your development, if you like. So it's just a grouping mechanism for applications. But you see in this case it's the same, because HTTP client only has one artifact in it, which is the HTTP client itself. And of course, so here you find a large number of different packages, some provided just by users, some of them are actually really like community driven or company backed tools. For example, SPECJ is a very big one. Do we find Android stuff in here? No, they're hosted themselves. We have Bartik. So it's a lot of popular libraries are just pre-compiled available. So that's the idea here. And if you want to search that, central. So how do we resolve the idea? Or how is it done in Maven? As a user, you would probably start this way by just looking for a particular package you're interested in. See, and that's kind of a normal normal search interface, basically. You're welcome. Okay, so let's say Scala. So Scala language, there you go. It's the artifact ID, Scala lang distribution, POM jar. That's what we get somewhere here. So group ID. So now I click on group ID. First of all, it showed everything that has a string Scala in it, right? Which can be a lot of stuff that's ridiculously off, but also some things that I'm interested in, which, for example, is the Scala language. So the artifact ID, again, the more specific one, it tells me basically the product, right? So in this case, the Scala language I'm interested in. Whereas the group ID is more like everything that has been provided by under this kind of Scala umbrella. So if I click on the group ID, I see everything that's related to the Scala language, for example, which is the compiler, the library, everything basically, actors, and so on. So Swing, so specific frameworks and so on for development for actor libraries, for example. But if I click now on the Scala library, then you see, so it gets more and more detailed, and you get some reference to the Java docs, the sources directly as a jar file, the compiled binary jar file, which you can immediately use, or the POM file itself, right? So it would directly link to the POM file, so that's this whole thing. And it basically just tells you how to build Scala from scratch. Has all the contributor information in there as well. And here they specified the dependencies down here. So it depends on the org.scala lang source files and on lamp, not sure what that is, the Dotty library, not sure what the purpose of that is, but anyway, it's a dependency. And that's basically how it would then be kind of usable. So my preferred way, the easiest way of then identifying, okay, what's the dependency, how do I not, include the dependency into my project. There's another search service which is kind of more comprehensive, covers more different repositories, but the biggest one is the Maven one itself. let's see, I just do it again for Scala. You also see the latest release and so on. That's more like a community-driven thing. And I'm interested in the latest version, 2.13, for example. So, and here, that's the interesting bit. Here you have the code snippet that you need to include in your POM file in order to download, for example, Scala. So that's the only thing that you would need to add. An example in the code that I just showed you earlier, which also relies on Scala, here. So that would be the dependency here that's added here. So you basically just Scala lang to a Scala library version 2.12. That's all you need. So then you have the Scala dependency included. And that's basically the idea here. So that's the idea of the Maven repository. Download or upload both the compilation specification, the whole build system specification, but also binaries and so on that you can immediately include in your project. And it has, this is actually still quite popular, and you'll come across it because it's not only has the specification for Maven, the Maven build system, but also for Gradle. So if you want to, for example, include Scala in Gradle, in Gradle, sorry. This is the statement you need to use. You just say compile and then group name, version, and so on, right? So it's the same thing. It's the group ID, the artifact, and then the version associated with this, right? So, and if you have, for example, a Scala build tool, that's the kind of statement you would need to use. Ivy uses this one, Grape, Leiningen, which is for closure, I think, and Builder, which is yet another build tool. They have different syntax, but they can use all the same repository. So it's kind of useful for you if you use sort of any library that should be centrally hosted, consider that as one possible option. Right, and this whole idea is actually continued to be used by Gradle as well. That's why it kind of was worthwhile to go over it. And if you want then run Maven, you basically do something like mvn install. So you have the install target, so it does everything until the installation of a product. If you want to do a run multiple lifecycle stages in sequence, you could do something like mvn clean install, so clean everything first, meaning delete everything that has been compiled previously, and then do a neat clean build from scratch. And if you, for example, want to clean and then afterwards not only install but also deploy, then you can run the deploy target as well here. So that's the key idea. So it's always very simple. There's a simple command that allows you to build the entire thing from scratch. So the yeah, it has challenges, right? So it's a bit Java centric, which is an issue. It's tough to keep track of the effective POM. So because of this hierarchy kind of approach, you need to have plugins for everything to do the most basic things like copying files from left to right or rename them. It's kind of very verbose. You saw that length of it's XML, so the lengths of the files are considerable, if not annoying. And probably one of the most annoying things in the meantime, especially for large projects, it doesn't keep track of the compilation state, right? So you compile this whole thing, and it's basically done. Every time you do a minor change to, let's say, one source file, you want to recompile, it goes through the entire chain again, right? So it doesn't do incremental compilation, for example, right? So it's a bit tedious in that respect. So yeah, so that was the idea. So why not use Gradle? Because it probably can integrate the best of all those worlds. So you have the idea of somewhat retaining the flexibility of end, which was the first one we talked about, which is just the different targets that are linked up, and the linking of targets is up to you. Then there was the concept of dependency management that was in Ivy. Haven't dealt with that myself, but most important influence was probably Maven, which introduced conventions. So you have a fixed life cycle, and you have multiple modules you can link, and so on. And then there was an idea of, okay, can we come up with a DSL, a domain-specific language that is, gives you more flexibility. On the one hand, allows you nearly to perform some sort of configuration-based deployment, while at the same time having programming language elements in there. So that was Gradle. And Gradle itself, or just to motivate that a bit more, again, not something you want to terribly be able to read, but the idea is basically the same stuff expressed in Maven on the top and at the bottom in Gradle. So it's a lot more concise there, right? So in the second case, we just say, okay, what's the group, what's the version of our product, what repositories are we using, what are the dependencies, but not having this complex specification as here. So one of the other strong features of Gradle, that's why I think you meet it again eventually, is that it works cross-platform. It works across different programming languages as well. So you can have sub-projects that have different programming languages from parent projects, which is a challenging one. Even though it's still somewhat centered around the JVM community. That means like Scala, Java, and so on, many of those. And Groovy is also based on the JVM, but it's in principle useful for C++ as well. It still works with conventions, but it gives you a flexibility of having also some sort of procedural code in addition to those configuration statements that you see. And it allows incremental builds. So that's the key idea of Gradle. I think, yeah. I'll probably give you a 10-minute break because you're suffering through, and then we can look into some more practical aspects of Gradle, just to explore that a bit, how